The first thing it says is to add two equations together. Now, this should not be difficult. If you add two things together and you can't actually add them, you put a plus sign between the two things. If said things are identical, then there are two of them. And if they're the exact opposites, they become a zero. Now, the only thing we have to do to get our identity is to divide by 2. And you can also put 1/2 of the number. Product to some identities. So that's how they got them. They took two equations, added or subtracted to get it. Okay? And so this is now your identities for sum to product. We're going to use the identity to rewrite. Now make sure when you are doing this lesson, you read the instructions, because sometimes it says to just rewrite it. Cosine, cosine. So I look for the one that has cosine, cosine. So it's the very last one. That is 1/2 of the cosine of 34 minus 39 plus the cosine of 34 plus 39. 34 minus 39 is a -5. 34 plus 39 is 73. What do you know about odd-even identities? The cosine of a negative is what?
Is positive.
It's the same as the positive value. Cosine of 5 plus cosine 73, and we're done. So you got to do, just rewrite it. Find the exact value means you're going to use your identity and then simplify it. Cosine sine. Cosine sine. 1/2 the sine of 5 pi over 24 plus the negative pi over 24 minus the sine of 5 pi over 24 minus a negative pi over 24. 5 minus 1 is 4 pi over 24, which reduces to what number? Pi over 6 minus 2 negatives are plus. 5 plus 1 is 6 pi over 24, which reduces to pi over 4. Now, pi over 6. For those of you that haven't figured out radians yet, the sine is 1/2. That's the 30 degrees. So we have 1/2, 1/2, and pi over 4 is 45 degrees. Radical 2 over 2. Luckily, I have a common denominator. 1 minus radical 2 over 2 times 1/2 is 1 minus radical 2 over 4. Exact value. I am not going to bother going through how to get these to get these. Okay? We're just going to use them. Are you okay with that?
Yeah.
Okay. So you trust that the people that came before us knew what they were doing and used the identities to develop the sum to product identity, right?
Right.
Okay, so we're good with that. All right. We have a sine plus a sine. Sine plus a sine is going to be 2 times your sine of 7 plus 11 over 2, cosine of 7 minus 11 over 2. 7 plus 11 divided by 2.
I almost said 77.
Not 77, no.
Just a little bit off.
7 minus 11 and the negative 4 over 2. And it is cosine. The odd even identity says it's the same as the positive. Find the exact value. This one is a cosine plus a cosine. So it's our third value, 2 cosine of 5 pi over 24 plus pi over 24, cosine of 5 pi over 24 minus pi over 24, and those are all divided by 2's. 5 plus 1 is 6. 6 24ths reduces to pi over 4 divided by 2. Am I going too fast? 5 minus 1 is 4. 4 over 24. And that one is also divided by 2. So pi over 4 divided by 2. What's wrong?
Just thinking.
Are you okay? Did I do something wrong?
No, you did. I don't even know what it is. So. I'm trying.
So you're okay?
No, yeah, everything's fine. I was just supposed to have the exact value. Is that it?
No,
Or
that's
we're
not.
gonna do that?
We're going to have to do something else. So what are we going to do?
The cosine.
This is pi over 4 divided by 2. That was our half angle. So looking back at your half angle identity from the last section,
So it's just
now I'm going to try to do this to where it's the cosine of pi over, so we've got 1 plus the cosine of pi over 4 divided by 2, and that is underneath times the cosine of the pi over 6. So 1 plus the cosine of pi over 6, and that is also underneath the square root, all being multiplied by the 2. Are you okay with the way I wrote that? The cosine of pi over 4 is radical 2 over 2. And that's underneath the radical there, underneath the radical here. 1 plus radical 3 over 2 divided by 2. Keep the 2 on the outside. Am I going too fast? All right. Are you okay if I get this common denominator and write 2 plus radical 2 over 2 divided by 2 Or did I skip too many steps? Are you okay with that? I'm going to go ahead and do 2 plus the square root of 2 then over 4. Doing the same thing on the other one. Common denominator is 2. 2 plus radical 3 over 2 divided by 2, which makes this 2 plus the square root of 3 over 4.
Do we have to simplify it?
Oh, yes, we do. You can't leave in our class the square root of 4 in the denominator. And the square root of 4 is
2.
2 plus the square root of 2 over 2. 2 plus the square root of 3 over 2. Are you okay if I go ahead and divide out one of those?
Yeah.
Okay. Now, let's see what you remember about multiplying radicals together. When can you multiply radicals together? And how do you multiply them? Okay, so if it were, here, let's do 5 instead of 4. If that were the square root of 5 times the square root of 6, then what would you get? The square root of 30. So you're just multiplying these numbers underneath the radical together. Are you okay with that? 2 plus the square root of 2, 2 plus the square root of 3, all over 2.
I hope the bottom 2 got canceled out.
The first one did. The second one did not. This was 2 times this product. This 2 divided this first one out. That leaves the second one there. Now, I would say stop there because you're going to have 2 things in the middle that are not going to be the same and you can't add them if you actually FOIL that out. If you did, it's not going to be wrong. You're going to have 2 square roots of 3 plus 2 square roots of 2 plus the square root of 6, all underneath the radical over 2. You can't simplify that any further. So either one of those would be fine. You okay with that? I would be happy if you just stopped here. Okay, consider that you have this equation, y equals a sine x plus b cosine x. If you're going to write out your right triangle, and this point AB tells me that this is A, this is B, the distance A and the distance B. Are you okay? Using the Pythagorean theorem, a squared plus b squared, take the square root, is going to be the hypotenuse. So the square root of a squared plus b squared. So the sine is the opposite over the hypotenuse. The cosine of that angle is the adjacent side over the hypotenuse. And the tangent is opposite over adjacent. Are you okay with that? We have the reduction formula, and we're going to use this idea to find the amplitude and the phase shift of this equation. In my equation, A is the number in front of the sine, B is the number in front of the cosine. Using the square root of A squared and B squared, then the number that's in front of the sine is the amplitude, yes? You okay with that? Helps if you can see it. 9 plus 25 is 34. This is the number that's in front of your sine, so the square root of 34 is the amplitude.
Those are squared.
Yes. A squared plus b squared. Are we good? Ready to move on? Now, we've got to figure out this phase shift, this alpha. How can I find what the angle alpha is? Well, go back up and look at what we just considered. If my triangle is drawn, then are you okay if I do in the third quadrant? And why would I draw it in the third quadrant?
Because both sine and cosine are negative.
Yeah, you've got -3 and -5, correct? If 3 is the number in front of your sine, then your -3 is going to be the distance here, and 5 is the distance here with the square root of 34 here. Are you okay with that? So the sine of alpha is going to be your opposite side over your hypotenuse. Taking this equation, how do I solve for the sine? How do I undo the trig function of sine to get the angle? What is the inverse of sine?
Secant or cosecant.
That's reciprocal. The arc sine is the inverse of the angle. These undo each other, giving the angle. Now, the calculator needs to be in what mode? Radian. The arc sine of a -5 divided by the square root. Let me just start over. -5 divided by the square root of 34. Now, because we are in the third quadrant, how do I find my reference angle? It's not going to be a -1.03. What if I were at, say, 225 degrees? How would I find that reference angle? Right. So because we're in radians, I need to do what? Add to pi. Pi is equivalent to 180. Whoops. That's not what I wanted to do. Subtract that answer. Do what?
Did you get a new calculator?
I am borrowing this calculator. So, yeah. The square root of 34. Let me put that back in there. And I need to add pi. So, are you good?
Why did you add pi?
Because we're in the third quadrant. If I were down here at 225 degrees, I would have to take it back to 180 degrees. Because we are in radian, we're going to do pi. So the angle, why do we do what?
Why do we need to find the reference?
because everything that we do is taken back to that first quadrant. Good question.
So what if it were to be in the second quadrant? Would you add something else?
If you're in the second quadrant, you're still going back to 180.
Okay.
And if you were in the fourth quadrant, you would go to 360 or 2 pi to take it back.
Gotcha.
39, rewrite the expression in the form of y equals a sine of x plus y, then graph one cycle finding amplitude, period, and phase shift.
And we thought this could get worse.
Oh, but it can. I mean, no. Okay, this looks like our reduction formula. Yes? Okay, so if we're going to rewrite it in A, that's the amplitude, sine of x plus c, what is my A and B?
So we're trying
What
to
is the
find
A and the B value?
through C.
Well, look at your reduction. Here's A, here's B. So the first capital A value for amplitude is the square root of the A squared plus the B squared. Correct? So the square root of 2 squared plus the square root of 2 squared.
4 squared is 2.
So that's the capital A value. That's the amplitude. Well, if you did a negative radical 2 squared, it would still be a plus. So it's fine. Now, do you want me to draw the triangle, or can I skip drawing the triangle and just look and use this value over here? Or are you okay? The sine of your angle alpha is going to be the B value. Which one of these is the B value?
Square root of 2. Wait.
Are you sure? It's the negative one.
Why?
The sine is opposite, which is the B value, over the hypotenuse. The B value is the one that's in front of the cosine. So it is a negative. All right, now, how do you undo a trig function? Arc sine. So the arc sine is saying, what angle gives me a negative radical 2 over 2? Which one gives you a radical 2 over 2?
45.
45. So we're 45 or pi over 4. Yes? Are you with me? The fact that it's negative tells me that I'm in which quadrant?
If A is the sine,
Because this was positive and this one was negative.
either quadrant 3 or 4.
You're in the fourth quadrant. Yeah. The reason why it's not in the third quadrant was because both of these were not negative.
Oh, gotcha.
If they were both negative, that would be both left and down. Okay, so this pi over 4 is the C value. Y equals 2, that's the A value, of the sine of x pi over 4. Now, do I put a plus or a minus?
Aha.
It is a minus. Now, what is the period? Tell her how you knew that.
I didn't. I really just guessed.
Where did it just pi over 4? I don't understand.
What angle gives you radical 2 over 2?
Oh,
Because it was negative square root 2 over 2.
Mhm.
Is that why? it's
Yeah.
minus?
And the period is 2 pi divided by the b value, and the b value here is 1. So that hasn't changed. So our period is 2 pi. And now you've got it to where you can just graph it.
Oh, that,